37. Space probes are separated from their launchers by exploding bolts. One half of the launcher is a 4,800 kilogram satellite. The other is a 1,500 kilogram launcher module, and the total energy they have after being separated is 5,000 joules. Right? So it's asking what are their velocities using the frame of reference in which they are at rest before separation. So they're at rest before separation. Here's one, here's the other. This one is 1,500 kilos, right? This one is 4,800 kilos. The bolts go off, and this one takes off this way, and that one takes off that way. So what happens when the bolts explode? Well, what's the total momentum before anything's moving? Well, total momentum beforehand, initial momentum is 0, right? Equals 0. And so what's the final momentum? Well, the final momentum is, we'll call the satellite M1, right? Final momentum is 4,800 kilograms times V1. Call its velocity V1. Now, the 1,500 kilogram piece is headed in the opposite direction, right? So its momentum is negative. So we're going to call it speed V2. So P final is 4,800 kilograms times V1 minus 1,500 kilograms times V2. And we know since momentum was a 0 beforehand that the total momentum of these two objects is still 0. Okay. Now, what's the other piece we know? We know that 5,000 joules is the total kinetic energy, right? So 5,000 joules times 4,800 kilograms times V1 squared plus 1/2 of 1,500 kilograms times V2 squared, right? So that is also what we know. The total kinetic energy is the sum of the kinetic energy of the two parts. Kinetic energy is a scalar. These two simply add. All right. So from this first equation right here, from that equation, 4,800 times V1 minus 1,500 times V2 equals 0, right? We can rewrite that. First is 4,800 kilograms V1 equals 1,500 kilograms V2, right? If we solve for V2 equals 4,800 divided by 1,500, V1 equals, all right, 4,800 divided by 1,500, 3.2 equals 3.2 V1. All right, so now we're going to take this 3.2 V1 and stick it in for V2 right there. Okay, so that gives us 5,000 joules equals 1/2 4,800 kilograms V1 squared plus 1/2 1,500 kilograms times, all right, 3.2 times V1 whole thing squared. All right, so the second piece, the last term, we can rewrite just a little bit as 5,000 joules equals, I'm going to change 2,400 kilograms. I'm going to use the 1/2. Go ahead and get that out of the way, right? Times V1 squared plus 750 kilograms, right? Times 3.2 squared, right? Times V1 squared. So now we can factor out the V1 squared without any problem. We've got 5,000 joules equals 2,400 kilograms plus 750 kilograms times 3.2 squared V1 squared. Here we go. What is all that? So 2,400 plus 750 times 3.2. Oh, 3.2 squared. So this is 10,080 kilograms times V1 squared. And I'm outside of math mode. All right, 10,080 kilograms times V1 squared. So this tells us V1 equals 5,000 joules divided by 10,080 kilograms equals, all right, 5,000 divided by 1080, 0.4, oh, my apologies, square root of all of that. Oh, 0.7 meters per second. All right, so V1 is 0.7 meters per second. And we know V2 is 3.2 times 0.7 meters per second, because V2 is 3.2 times V1, right? So equals 3.2 times 0.7 is 2.3 meters per second. And that's V1 and that's V2. All right, what are the subsequent velocities? And there we have it, 0.7 meters per second and 2.3 meters per second. And we're now done with problem 37.